Hey everyone, in this video I'm going to show how to set up YOLO26 models to run on the Jetson Orin Nano to achieve blazing fast inference speeds with object detection. YOLO26 is a state-of-the-art computer vision model that was just released by Ultralytics. It implements a variety of improvements that help it be faster and more accurate than previous generations of YOLO. Features like NMS-free inference, DFL removal, improved loss functions, and new training optimizers help YOLO26 run 43% faster on CPUs and have better small object detection accuracy. This video gives step-by-step instructions showing how to set up YOLO26 on the Orin Nano and run it on a live USB camera with a custom Python script. I'll also show an example of how YOLO26 can be used in cool edge vision AI applications like an example TrainTracker smart camera that I made that counts the number and type of cars in a passing train. This video is sponsored by Ultralytics, the company that created YOLO26 and made it amazingly easy and accessible to train YOLO models. Thanks, Ultralytics. All right, let's get to it.
The first thing we need to do is install Jetpack on the Orin Nano. Jetpack is an SDK that includes an operating system, software, and libraries for Jetson platforms. I recommend starting with a fresh install. First, go to the Jetson Orin Nano Get Started guide, which I've linked in the video description below. The guide has clear instructions on how to set up the Orin Nano, so I'm going to move pretty quickly through this part. If you just got a new Nano, check to make sure you have the right firmware versions by following the instructions here. After you've confirmed your firmware version, follow the next steps to set up the microSD card image. However, instead of downloading the latest version of Jetpack, we need to download Jetpack version 6.1. That's the latest version officially supported by Ultralytics. Google search for Jetpack 6.1 and click on the first result. Make sure it says Jetpack 6.1 on the page, and then go download the SD card image for the Jetson Orin Nano Super Developer Kit. It's a 10 GB download, so it's going to take a while. When it's downloaded, continue following the instructions to flash it to a microSD card. Again, it takes a while, so feel free to pause this video while you work through each step. Once the SD card is ready, put the card in the Jetson Nano and power it on. Click through the OS setup questions and use default options. Make sure to connect to the internet. Okay, we made it to the desktop. First, click on the icon in the corner and switch the power mode to Max N. This puts the Nano in super performance mode so it runs the YOLO models as fast as possible. Next, let's update the Nano. Open a terminal and issue sudo apt update and sudo apt upgrade -y. And put in your password. And there we go. The upgrade can take about 20 minutes. Once the upgrade's completed, install pip by first issuing sudo apt install python 3-pip-y. Okay, and then issue pip install -u pip. All right, the Nano's updated and we're ready to install Ultralytics. For the most part, we'll be following along with this guide from the Ultralytics page. You can find a link to it in the video description below. I made a GitHub repository with code and examples for running YOLO models. Download it and move into the folder by issuing git clone https://github.com/edge-electronics/train and deploy YOLO models.git. And then space YOLO, Y-O-L-O. Then issue cd YOLO. The repository includes a bash script that automatically runs commands for downloading and installing YOLO. Run the script by issuing bash utils/jetson_install_yolo.sh. This script will install Ultralytics, PyTorch, and other libraries that are needed for running YOLO. It downloads about a gigabyte's worth of packages, so it takes a while to finish. Go grab a drink or take a break while it's working. Once it finishes, reboot the Jetson Nano by issuing sudo reboot now. Now that Ultralytics is installed, we can set up and run a YOLO26 model. You have two options. You can use an off-the-shelf model trained to detect common objects, or you can use a custom model trained to detect your own objects. Let's start with an off-the-shelf model. There's a variety of model sizes available, ranging from nano to extra large. This chart shows the relative speed and accuracy for the model options. Smaller models are faster but less accurate, while larger models run slower but have higher accuracy. Generally, I like using the small size YOLO26S model because it has good accuracy and it's still lightweight enough to run in real time on edge devices. Ultralytics makes it easy to download a model and convert it to TensorRT format, which is optimized for running on NVIDIA Jetson platforms. Open a terminal and move back into the YOLO folder with cd YOLO. Then download and convert a YOLO26S model by issuing YOLO export model equal YOLO26s.pt, format equals engine, and half equals true. The command takes about 10 minutes to run. It downloads the YOLO26S file and then runs NVIDIA's conversion script to convert it to TensorRT format. The half equals true option tells it to export the model in floating point 16 format to take advantage of NVIDIA's optimized FP16 architecture. This gives us a big boost in performance with zero effort on our part. Once the command is finished, you'll have a YOLO26s.engine file in the YOLO folder. This contains the YOLO26 model in TensorRT format. Now we're ready to run the model. I wrote a custom Python script for running YOLO models on images, videos, or cameras. It loads frames from the image source, runs inference on each frame, and counts the total number of objects, then displays the results. Let's try it out on a camera. First, plug a USB camera into your Jetson Nano. Then, run the script by issuing python YOLO_detect.py --model equal YOLO26s.engine --source equals USB 0 and resolution equals 1280 by 720. A window will open showing the live camera stream with detection results drawn on each frame. So the YOLO26S model does a pretty good job of detecting common objects. And it definitely runs fast. It runs 20-25 FPS, which is more than enough for real-time object detection applications. It's certainly much faster than the Raspberry Pi, and again, does a pretty good job. You can press Q to quit the program. You can also use a custom YOLO model that's been trained to detect unique objects. For example, I created a model called TrainTracker to detect different types of train cars. This model is contained in this TrainTracker2.pt file, which I'll move into the YOLO folder, along with a test video to use. I can convert the model to TensorRT format by issuing YOLO export model equals TrainTracker2.pt and format equals engine and half equals true. Now that it's exported, I'll run it on this video of trains by issuing python YOLO_detect.py, model is TrainTracker2.pt, .engine, source is trainvideo1.mp4. Okay, so the script will load the custom model and then run it on each frame of this video, and it displays the inference result for each frame. As you can see, my custom YOLO26S model does a pretty good job at identifying different types of trains. Looks like it needs help with a gondola train there, but generally it's doing a great job of seeing each of the different types of train cars. So it's pretty cool. To see how to train your own YOLO models for detecting custom objects, check out my How to Train YOLO Models in Google Colab video, which is linked in the description below.
Having a small but powerful compute platform like the Jetson Orin Nano unlocks a lot of cool applications for edge vision AI. As an example, I made a TrainTracker application that is basically a wildlife camera for trains. It runs YOLO26 on the Jetson Orin Nano to capture data about passing trains. Let's go check it out.
I built a small enclosure for the Nano and then left it attached to a post near the train tracks. The Nano continuously runs my YOLO26S model to watch for trains. When it sees a train, it starts counting the number and type of each car in the train. It uses object tracking to make sure it only counts each train once. After the last car in the train passes, the program summarizes the information and sends it to me in an email. It also records a video of the train and saves it on the hard drive. I uploaded all of the code for this program to GitHub, so feel free to check it out and see how it works.
At this point, you should have YOLO26 up and running on your Orin Nano. The huge compute power of the Nano, plus the flexibility and accuracy of YOLO, unlock a huge number of potential edge vision AI applications. See if you can come up with your own fun or interesting programs that use YOLO26 on the Nano. Check out my YOLO GitHub repository linked in the description below for more YOLO code examples. And keep an eye on my channel for more tutorial videos. Thank you for watching this video and good luck with your projects. See you next time.